Hello everyone, welcome back. So this is going to be our lab session on DQC. So we'll understand, what are the different types of DQC checks we can write. So if you recall our previous lab on fact table load, so we had bunch of scripts to load dimension table and then finally load the fact table. So we'll using that example, we'll continue our data quality checks for that. So how can we write data quality checks for dimensions table and fact table? So let's get started. So starting with completeness check. So as we saw in our previous session, completeness check is basically it checks whether mandatory fields in dimensions or fact tables are filled or not. Basically it should be non-null if it is required. So for example, if we have to check null values in mandatory fields, like driver ID is mandatory, right, in dim drivers table. So or driver ID is mandatory, or name is mandatory, phone is mandatory, right? So it should not be null. So what this check is doing, it is checking, given this dim drivers table, is there any driver ID which is of null value, or name of null value, or phone number of null value? If there is any, then it may cause issues when we try to generate some insights or generate reports, right? Likewise, in fact bookings, we can check different dimension keys are null or not. For example, passenger key shouldn't be null, driver key shouldn't be null, because if a ride is completed, then there must be one associated passenger and one associated driver to it, right? And one associated payment method to it, right? So in fact bookings, we should have all of these keys available. So that's what we are doing here. We are checking if there is any passenger key which is of null value, or driver key or payment method key of null value. So this ensures our dimensions table or fact table is complete, it is meeting the requirement and all data is accurate and complete. Now if we talk about uniqueness check, so it ensures primary key or unique fields are not duplicated. So basically if you look at dim drivers, so if dim drivers is of SCD1 type, okay, then driver ID cannot be duplicated, right? If it is SCD2 type, then there is another way, like for valid record there should not be two different values, right? So assuming, let's say, dim driver is SCD1, then we cannot have two different driver ID in the same dim drivers, because SCD doesn't contain history and there should not be any duplicates. So that's what it is doing, it is checking if there is any duplicate value or not. Likewise, in fact bookings, if you recall, in our fact table, we were storing all of the facts in raw form, raw facts, not aggregated at hourly or daily level. So that's why in fact bookings we will have booking ID in the table, and booking ID cannot be duplicated, right? So if there is any let's say ETL pipeline issue, or some due to some dirty data, if we are seeing two different records, so obviously there is some issue in the data, right? So that's why we are checking, in the fact bookings there should not be any duplicated booking ID. Okay, so this is uniqueness check. Now if we talk about referential integrity check, so this ensures foreign keys in the fact table reference valid keys in the dimension tables. So for example, if we join fact bookings and dim passengers, so we should get all of the keys matching in the dim passengers. So think of this, if you recall, we had to first load all of the dimensions and then fact table, right? And let's say by any chance in dim passengers some records are not inserted, and then we kick off our fact bookings ETL load. So then what happens, some keys will be missing, right? And you might end up seeing some null values. So basically that's what we are checking. And if you have to ensure, so this null passenger key causes data issue in the fact tables and it should not be there. And same way, if we check for driver key, so it should not be null, because any booking has an associated driver and passenger, so the key should always be there. So this is referential integrity check. Fourth is ren check. So it validates numeric fields are within the expected range. Okay, so for example, in real world, if any ride is happening the fare amount cannot be like 10,000 USD, right? That's very, rare to happen. Or total distance covered in that ride cannot be like 1,000 kilometer, right? Until and unless it's a city to city ride, that's a different case, but which is a rare scenario. But assume that the operation is happening only within city, then we cannot have like 1,000 kilometer traveled in one ride. So obviously it's an invalid data. So those sort of REN check we can do, and it ensures our data is accurate in the fact table. Now if we talk about consistency check, so it verifies that related fields are consistent within the dataset. And so if you look here, now let's assume this dim drivers is SCD2 type, for example. Then what happened, if you recall, like for every change happening in the driver attributes, we used to have different rows created in the dimension table. We used to expire the previous row and then old row, and then generate a new row for the drivers with latest attribute. So in each case, effective start date cannot be greater than effective end date, right? Because each state represents from this state to this state, from effective start date to effective end date, this record is valid. So we cannot have any case where effective start date is greater than effective end date, right, which is like invalid, right? So if due to any some, let's say, logic issue, if this data gets populated, obviously this will cause a lot of issue when you try to generate some reports for the drivers. So this is what we are checking, consistency check. And if you look here, like mismatched pickup and drop off location. So for example, if any ride is happening, so the passenger will be traveling from point A to point B, right? So each point will have different area name or city name, area name or street name, and each point will have their own geohash value, right? So corresponding location key will be different. Pickup location key will be 1 and drop off location key will be 2, right? Or any different value. So it cannot be same, like ride cannot happen like start there and finish there, and then we have some distance value and amount USD, right? So this is invalid record. So that's what we are checking here. Okay, and now if we talk about data format check, so this ensures data is following some standard formats like phone numbers or dates. So if you look here in dim drivers, so phone numbers should be like 10 to 15 digits. If the let's say system allows, that phone number can have 10 to 15 digits. So whatever data we are receiving in dim drivers table, the phone number should exactly match this expression. So this is what we are doing here. This is what we are checking, like if the phone numbers are within the range or not. Okay, and likewise, if you recall, dim date or in fact table, like date key, the date key is in integer of YYMMDD format, and this is what we are checking here. So this date key should always be 8-digit integer value, right? Now looking at this validity for effective dates in dim drivers. So let's say if this dim driver is of SCD type 2, then we should have a check where there are no overlapping date ranges for the same driver, right? And this is what it is doing. So for each driver we are checking is there any overlapping dates or not. Okay, now if we talk about handling active record in dim drivers, assuming dim drivers is now SCD2, so we cannot have like two active record for the same driver ID, right? So if you recall the SCD2 implementation for dim drivers, whenever any attribute change was happening, age row current used to be expired, and then with the latest attribute we used to insert data and marking the age row current equal to 1. So at any point of time in dim drivers, a driver cannot have two active records. If it is there, then it will cause a lot of issue. If you try to join dim drivers with the fact bookings table and generate some insights, it will cause a lot of duplicate data issue. Okay, now historical data accuracy. So in dim drivers, we are again checking some if the records are consistent or not. So based on like given driver ID, so we cannot have effective end date less than effective start date, right? So that's what we are checking here. So this is for just for demonstration, but obviously like if you are doing a real world project implementation, so each business has different use case requirements and different entities, different facts, and based on that like whatever is important and critical we feel that may affect the report, we should have data quality checks for that. So I hope this has given you enough understanding like how we can write scripts if you're using any data quality tools like Great Expectations or DBT. So you can like implement all of these data quality checks there, or you can just write it in your data pipeline itself. Let's say if you're writing some Spark code, so you can write, or SQL code, you can have one step after data pipeline finish, then kick off this data quality check. So it depends like how you're designing the data pipeline. So I hope this session has given enough understanding on implementing data quality checks on dimensions table and fact table. So feel free to do some hands-on, like insert some dummy data. You have already been given all of this DTL and ETL scripts. Insert some dummy data and try to run all of these rules. So I hope this has been helpful, and I'll see you in the next session.